So, real quick, what's your major?
Pre-physical therapy.
Pre-physical therapy?
Yeah.
What science classes have you had so far?
Chemistry and biology.
Biology.
In college, yeah.
In college? Did you take anything in high school or?
Yeah, well, like the required. I took physics junior year, but.
Okay. What'd you think of that?
Wasn't very good at it.
Wasn't very good. It's okay. I'm not very good at it either. I just like to struggle through things. I think this is your pen. Let's see. Okay, so I'm gonna kind of just prep this real quick. I'm not really looking for any right answers on any of this stuff. I just want to know what you think of these situations and like how you think they're happening and what's going on. All right, is that fair? So feel free to be as open. If you think it's weird, don't worry about saying it. If it's in your head, just say it. Because I'm not looking, like I said, I'm not looking for right answers. I just want to know what you think. We're gonna be going over a couple different scenarios about energy and like what you think is happening to the energy in these situations. How is it like getting created and stuff like that, and where it goes. So those are a couple things to just kind of think about while you're doing it and explain to me. Let's see. Well. First one is lighting a match on fire. I'm not gonna actually light it on fire in here. Well, I'm gonna do one really quick. Okay? But, so, and then you can just kind of look at all these other ones, and I just want you to tell me what you think's happening to it when it's, from when I light it, and when it starts burning, and then after that, okay?
Alright.
Ready? First one. So you get an idea of what happens. That's fire.
Yeah.
Alright, hopefully that doesn't get me in trouble in here.
Hopefully that'd be really bad.
Yeah, especially.
Set up the fire alarm.
First thing I did, right? That would be my luck. Okay, so feel free to kind of like play with the matches, look at them. What do you think happened with that match?
Well, I'm trying to think. So I know in like chemistry, it's like a combustion reaction.
Okay.
It's like what is it? Like an organic compound, and then oxygen, and then comes out carbon dioxide and water, which is why it's black. And it needs the friction to like kickstart it to start the reaction.
Okay. What do you mean by the friction to kickstart?
Like frictionless.
Okay. And what does that do?
Produces, I guess, heat.
Produces heat. How does it produce heat?
Friction produces heat.
Friction produces heat. Okay. Oh, that's fair. So where's the energy coming from to produce that friction?
It's in the molecules already.
Could you explain that a little more?
Like, in, I guess, the bonds between the chemicals, because electrons are all.
Yeah, they could go everywhere.
Yeah.
Okay.
Yeah. I think that's pretty.
That's it?
That's where that's where I
Okay.
think the energy's coming from.
Okay. Do you think there's more energy before you light it or after?
It's the same,
Why is it the same?
because the energy cannot be created or destroyed.
Okay.
So,
Okay.
yeah.
Anything else? No? You're good? You're satisfied?
Yeah, I feel like it's pretty solid.
Okay. So you feel like you have a pretty good understanding of that?
Kinda, yeah.
Okay.
I think.
Okay. Let's see.
This pencil.
Covered that? We good? Alright. Okay. Next, I'm going to have you touch these two blocks and tell me which one you think is colder.
Feels like that one.
This one?
Yeah.
Okay. Why do you think that one's colder? Just because it feels like it?
I wanna break it. Well, I'm trying to like.
No, that's fine. Hey, whatever pops in your head, don't worry about it.
I feel like it has to do with the fact that they're different materials, for sure.
Okay. All right.
Nothing.
Nothing. That's all. Okay. So let's see real quick. Okay. So you're saying this one feels colder and this one feels warmer.
Yeah.
Okay. And you're saying this. Do you think this one is colder? That's what you're saying.
Like it feels colder, but I don't know necessarily that it's actually colder.
Okay. Well, I have this thing here. Do you know what this is?
Mm-hmm.
You do?
Oh no.
Oh, it basically checks the temperature. So what I want you to do, it's like a little laser thing. You just point it, see a little laser. It reads the temperature, like my hand. I'm very cold apparently.
Yeah.
All right. So what if I told you these were the exact same temperature? Would you believe me?
Yeah.
Because this is an experiment. I'm telling you that. Test it out. Let's see if it works this time.
Wait, do I press this button?
No, the trigger button.
The trigger button.
Mm-hmm.
Is that one 71 point? I'm waiting for it to stop. I'm gonna go with 5. because
Okay.
It keeps going to that.
Whoa.
That one's colder.
It's close enough.
Close enough to the same.
0.5. Yeah. Well, also we were touching it, so your hands have a little bit.
Touch this one up. So
Cool.
we're gonna sit.
So
the purposes of the same.
yes, the purpose of my interview, we're gonna say they're the same. That way, I get all my points. No. Okay. So now, if I place an ice cube on one of these, which one do you think will melt faster, knowing that they're the same temperature?
I feel like the one that's gonna melt faster is this
Why do you say that?
because I feel like this is a more I can't think of the word right now, but it like transfers energy easier, like heat.
Okay. Keep going.
Yeah. I don't know. Like, I like know what I'm like trying to say, but like I can't like
That's okay.
say it.
Word vomit.
I don't know. I think it's the material. Like how like what I'm trying to say is like you know how like metal like it'll get colder like way faster than like a piece of wood will.
Okay.
Because I can't say why. I don't know why. But like I'm trying to like say it's kind of like that.
What do you think's happening though? If you had to explain it, if I like. What would you do? Let's go ahead and do this real quick.
Yeah, just do that. Look at that. Guessed right.
Now, tell me why that's happening.
I feel like it has to do with the surface. Like how because I feel like it has to do with, you know how like electricity goes through metal really easily and it's a conductor?
Okay.
I feel like that has to do with it, like with energy being able to transfer through faster.
So the energy's transferring through faster because it's a better conductor.
Yeah, I feel like it's
Okay.
the wrong word, but yeah.
Hey, it's your words. Huh? Why is this a better conductor than the other one?
I don't know. That's why I'm like, I can't, that's why I've been like struggling because I don't know why it does that. I just know that it does.
Okay, well, what other experiences have you had? And just, I mean, like I said, I know it's kind of tough to try and figure out why, but
Um, um, trying to think. I don't know.
take your time, no rush.
Um, nothing.
Nothing.
Um, why? What does it do that? I really can't think of
I mean,
anything.
what was that? Because this one felt colder, right?
Yeah,
And this one, you said felt warmer, but they're actually the same temperature.
yeah.
We figured out. So if this one felt colder, and why did something cold melt faster? What do you think? Like, what's transferring what?
So, I know there's heat energy, and it goes from hot to cold, and when energy goes from hot to cold, that's why it feels cold. So I'm gonna guess because this is warmer than the ice, it transferred heat because it's warmer faster to the ice. So it felt colder. As if like my hand was warmer than it, so the heat from my hand went faster into this.
Okay. So the heat. Okay, so you're saying the heat from your hand transferred into here faster,
Yes.
and the heat from this transferred to the ice cube
Faster
faster.
than it would have with this.
Okay. How do you think that happens?
It's like, this way, and then like that part I'm just like, blank. I don't know, maybe because the way the molecules are.
What do you mean?
Trying to like think.
Okay.
Like, see, I feel like electrons have something to do with it. Because electrons make everything weird.
How do they make everything weird?
Like, electrons determine like the charge of like I can't think of the word. The element. So like the electrons are kind of what make it do the funky stuff, like Na goes to Cl and that kind of thing.
Okay. So that's salt.
Yes.
So you're saying how they bond? Is that what you're?
Yeah.
Okay. So what do you mean by the electrons bond in here?
Maybe they're differently bonded. I don't know.
Differently bonded than what?
Than that.
Okay. How do you think they're different?
Because different charges, I don't know, on the ions.
Okay. So which one has more, which one has less? What do you think about that?
I feel like in this one, it's like bonds with electrons are like shared equally, so they're not going all over the place. They're kind of like centralized in one place. And then like this one, it's they're more. Actually, no, it's the other way around. These are like more solidly held on to the molecule, so they're not transferring energy. They're just kind of chilling.
Okay.
And these, they're not, so it's easier to transfer energy.
Well, okay. What makes it easier to transfer energy about these not having a tighter bond?
Because the electrons can do whatever they want.
Can you go a little further on which one they can do whatever they want?
Like in this one, because the electrons are held onto the molecule, they're like there, stuck.
Okay.
They can't really, I mean, they can like go, but they're not gonna be released as easily. And then on this one, they're not held on as tightly, so they can just fly off whenever they want, I guess.
Kind of. So you're saying the electrons are more free moving in this one than this one?
Yeah.
Okay. So how does that free movement allow energy to transfer?
Because the movement is energy.
What do you mean by that?
Like it's already, is it kinetic energy? And kinetic energy can easily be transferred to heat.
You said
Well, heat is kinetic energy, pretty much.
heat is kinetic energy. Okay. What is kinetic energy to you?
Movement.
Movement?
Yeah.
Okay.
And then like temperature is the measurement of the movement.
Temperature's the measurement. Okay. So then, okay. Cool. Let's see. That's pretty good. It's tough to explain your brain sometimes, isn't it?
Yeah.
Okay. You're doing good. You're doing good.
I feel like I'm just making stuff up. That's pretty much what I'm doing
That's what science is. You make it up and then test whether it's right.
Very true.
Do you have any other thoughts about, like, because like, this one has been done for a while, right? This one's still going. Like, it's not even, I wouldn't even say halfway. Do you have any thoughts about that?
I feel like what I said before summed it up.
Okay, all right. Well, let me clean this mess up real quick. Boom. All right. I think it's cool now. Okay. So we're gonna be using this, we're not lighting any more matches.
Okay.
What I want you to do is just kind of take the box and slide it across the table and just play with it and then do that, throw it, slide it like, so why do you think the box is moving and why do you think it stops? And what's going on with the energy in there?
Friction. I know, like, so there's the thing where it's not gonna move unless the guy doesn't move.
Okay.
Or a force is active. And I know it stops because a force was acted on it, which was friction. I don't know.
Did that box have energy before you touched it?
Yes.
Why?
Potential energy.
What's that?
The ability to do work.
The ability to do work. Okay, could you explain that anymore?
It's just like the energy that can be turned into something else, I guess.
Okay. So, before you touch it, it has potential energy?
Yeah.
What happens after you touch it?
It turns into, let's see, kinetic energy. 'Cause
Oh.
it's moving.
Okay. How does it change from potential to kinetic, and why?
Because it started moving. I don't know, because it started making it move.
Okay.
So the energy had to go somewhere
Where did it go?
into kinetic energy.
Into kinetic. So does it still have kinetic energy right now?
No.
Okay, so does it have potential energy right now? After you touch it?
Yeah.
Yeah. Okay, hey, like I said, no right answers, it's all what you think.
Yeah. I'm gonna say yeah.
Yeah, okay. Why?
It still has the ability to move.
Okay. Does it have more potential energy before or after you touched it?
I'm gonna say
Okay. You know about that?
or it's the same. I mean,
Why?
like, so I know like the amount of energy is the same the whole time. I'm gonna say, yeah, I'm gonna stick with before. Because energy, not all of it's gonna go to kinetic, some of it's gonna be like heat. Because it's moving, like the friction produces heat.
Okay.
It's gonna have a little bit. So I'm gonna say it's lower at the end because some of the energy was transferred
Transferred where?
to the heat.
To the heat? Where did the heat go? And how was this heat created?
The friction.
So the friction of you sliding it generated heat?
Yeah.
Okay. So, could you explain to me, just in terms of energy, starting with the potential when you touch it, how it switches and where it goes and what types of energy are in this scenario as you do it?
So that's potential. Then it's kinetic. I feel like it's the better word is mechanical, but I'm not really sure what makes mechanical and kinetic different. So it turns into like movement, energy, and heat at the same time because it's like moving and the friction and the heat's like escaping from it.
Escaping,
Yes.
okay.
And then at the end, I guess it's a potential. Back to potential.
Okay. So you're saying it goes from potential to kinetic and friction?
Well, heat.
Heat, okay, so potential to kinetic and heat, and then back to potential.
Yeah.
Okay, and you said there was more potential at the beginning,
Yeah.
right? Do you have more kinetic and heat than you did potential?
No.
Why not?
Energy can't be created or destroyed
Why do you say that?
because Newton said so.
Newton said so, okay, okay. So, so then potential, heat and kinetic, and you're saying this is the same amount, and then you said there was less potential at the end.
I feel like if this was like, sorry,
You're fine.
if this was like a reaction, it would have like potential in the beginning and then like produce kinetic friction. motion and the little bit of potential left. And it would all, like, both sides would be equal.
Both sides of what?
The equation I just did on the table.
Are you saying potential and kinetic and heat?
And okay.
Okay, go for it.
I'm gonna say, so it's got like potential, and then imagine like an arrow, and then it's gonna have kinetic and heat, and then another arrow potential, and then all of these are equal.
All of them are equal.
Yeah, I just rethought it.
Rethought it? Okay. So why do you say they're all equal now versus, because you first said these two potentials were different. So why do you say they're all equal now?
Because I feel like it has the same potential energy like here and here, because the only difference is like the movement.
Okay.
Well, I mean like placement on the table.
This one. Okay.
Like I could still move it whether it was here or here.
Okay. So something in this middle area, when you moved it, there's a change of energy.
Yeah.
And then it changes back after you move it?
Yeah.
Okay. Why do you think that happens?
Because I moved it.
Because you moved it. Okay. So are you the energy?
No. I am. Well, I guess I put like some energy on it. Some like moving it. So I guess it would be like, cause I put some energy into it and moving it.
Okay.
So I am some energy.
Some energy. Okay.
No, not all of it.
No. So, okay. So you supplied energy to it.
Yes.
Okay. And you're saying it changed types of energy because you moved it.
Yeah.
Okay. So what kind of energy did you provide to it, if you provided energy?
I'm gonna say mechanical.
Oh, what's mechanical?
Isn't that kind of like the energy of movement? Kind of, but it's different.
Kind of. Explain, can you explain a little more?
I'm trying to remember why they're different.
It's like, hey, you don't have to remember why. It's just, you can even just say what you think. Like I said, there's no right
like,
answers.
What makes it different is what I'm trying to think about.
Okay.
Because I know they're different. I know mechanical and kinetic are definitely different.
Okay.
Maybe because I made it move. Hang on, what was the question again?
Oh wow, I forgot my question. Oh, what is mechanical energy?
Oh, I think it's kind of like making things.
Okay. And what's kinetic energy?
The movement.
Okay. So then, could you explain the difference between the two using those two definitions you just said?
So, I'm like making it move, and the kinetic is just like the movement itself.
Okay. Okay. So, okay. So how is it different when you move it like this versus when you throw it like that?
Well, I feel like there's I feel like it's the same because when I like do this, it's just a smaller amount distributed over a longer period of time. This is just all of it at once.
Okay. Oh, can you explain that a little more? What do you mean? What is all of it, and what do you mean by?
Like the mechanical energy. That was your question, right?
Yes, the difference between when you push it and when you slide. Does one scenario have more energy than the other?
I feel like it's the same because the mechanical energy is like distributed over like a longer period of time. Because I'm like, in this, it's like I'm putting in more energy, but it's all at once instead of over time.
Okay. Okay. So, is there more potential energy in the beginning when you slide it than when you throw it, or the other way around?
I'm gonna say there's more when I take that back. When I said before, I think it's less mechanical energy when you throw it, but more potential energy, and then it's more mechanical energy but less potential.
Okay. Okay.
Yeah.
Cool. I got any more questions for you? You're doing really good. Let's see. Oh, that's good enough for me.
Cool.
Like, thank God, what have we done? I bet you can tell me this is the last time I ever do anything for you.
I was so worried. She texted me, "Can you do me a huge favor?" And I was like, "What?"
Alright, last thing we're gonna do. Play with the bouncy ball for a second. Just kind of bounce it, drop it from different heights, look at it, and just try and think about energy in this scenario and stuff. I'm gonna ask you a question here in a minute about it. It's just keep playing with. What kind of energy do you think's in this situation?
Well, it has a lot of potential when I like hold it up. And then there's like potential, then it falls, and it's kinetic.
Okay. So, when is it potential and when is it kinetic?
Potential at the top, kinetic when it's like falling and moving.
Okay. Is there the same amount of energy throughout the whole situation?
Yes.
Okay, can you explain that?
Energy cannot be created and destroyed.
Okay, I agree. So, why does the ball bounce back up then?
I feel like it has to do with like force. So it's like falling, there's like gravity pulling on it, and then the table pushes back up, and it bounces up.
Okay. Does it bounce back up to the same height?
Yeah.
Does? Every time?
No.
No. Why not?
Because energy like escapes.
It escapes. How so?
It's a bad word. And the
No, it's not a bad
energy is like so it like falls and then bounces like to the same height and then lower and lower and lower. And that's because like solid energy is potential and kinetic. Potential and kinetic. But then like in that process, some of the energy is given off as like heat, and there's like friction with the air.
Okay. Okay. So where's the heat given off in?
Because it's moving. When it's moving, because of the friction. Because friction produces heat.
So is the friction only between the air? Is that what you said? Can you explain what that is? Like what you mean by that?
Because the ball has to kind of like push through all of the air molecules, like make room for itself.
Okay.
So it causes them to like rub against it.
Okay. So when does it lose energy?
Like, I feel like escape or loss is the wrong word, because I know the energy is just converted to something else.
What do you mean?
Like, because energy isn't completely destroyed. Like, the energy doesn't just like disappear, it just turns into something else. Like mechanical, heat,
Okay.
all that stuff.
So, and you said the energy, it starts at potential,
Yeah,
and then what happens?
kinetic,
Kinetic when?
like when it starts moving.
Okay. Oh, sorry. So it goes from potential to kinetic, and then when is it losing the energy?
Like, as it's moving, because it's pushing, well, it loses like very little on like the first bounce, because it'll bounce to the same height, and it loses like little by little as it bounces through the friction and the very, very little heat. And
So it's generating friction and heat is how it loses energy?
yeah,
Okay, okay. And you said it loses a little the first time,
yeah,
and then it bounces back up to the same height?
yeah.
Okay. How does it do that if it loses energy? Does it gain more? It will have more potential energy if you hold it higher, lower?
It'll have more of that, more potential energy the higher I hold it.
Okay, why is that?
Because it'll, like, when I drop it, there'll be more kinetic energy. Versus if I dropped it from here.
Why?
Because it moves more.
It moves more. Okay, okay. Alright. Is there any transfer of energy between the ball and the table? Or is it only through the air? Is it potential and kinetic the whole time?
I feel like there is a transfer of energy to the table that's like, because it kind of makes the table like move a little bit.
Okay.
And it makes noise. So some of it's converted to sound energy, and let's see. Kinetic on the table. So it's like kinetic and the ball, and then like movement in the table.
Okay. So there's a transfer of kinetic energy between the ball and the table? Is that what you're saying?
Yeah.
Okay. Why is that? Because the table's moving?
Yeah, so like it kind of makes the table vibrate a little bit when it hits it.
Okay. So when the ball hits the table, is it kinetic energy when it hits the table and as it's touching the table?
Yeah,
Yeah. Okay. Why do you think that?
because it's moving still. Like you might not be able to see it, but like it's still moving on like a smaller scale.
Okay. So could you real quick, you don't have to bounce it, or you can if you want, explain to me through each step what kind of energy is in each like throughout the whole process?
So there's potential, and then kinetic, and then it's like, some of it's transferred to the table, and there's like sound energy, and then it bounces back up to the same height, and it just, see,
So what kind of energy is it on the way back up?
I think it's still kinetic, but it's kind of like converting back to potential. So there's like still the same amount of energy. It's just like,
Okay.
because the ball kind of like slows down as it goes up,
Okay.
that it's like converting back to potential.
So it's like changing as it goes back up?
Yeah.
Is it changing as it falls too?
Yeah. Now I'm thinking about it. It's like converting from potential to kinetic as it goes down, because it has less kinetic energy like the closer it is to the table. And then when it goes back up, the higher it is, the more potential, but the less kinetic because it's moving slower.
Okay.
And it like moves faster as it.
Okay. Real quick, so you said that it has potential and then it transfers to kinetic. You said it has less kinetic energy as it gets to the table?
It's more,
More.
because like all the potential is gone. So
Okay.
it's all kinetic.
Okay. So it's all kinetic on here.
Yeah.
And then you say there's sound energy and heat or friction, or is the friction is in the air?
The friction is in the air.
Okay.
Yeah.
And could you explain to me about the sound energy, what you mean by that, and
The noise.
the noise? Okay. So the noise, it gives off a type of energy?
Yeah.
Okay. Okay. And then, so after it bounces, explain me again as it's going up, what's happening?
The kinetic is converting back to potential as it goes back up.
Okay. How long does it do that for? How long is it, this
Until
energy?
it reaches like the peak, then it's back all to potential, and then it falls back down.
Okay. Will it just keep bouncing forever, or?
No. Eventually it'll all of the energy will escape through like sound and friction and heat and
Okay. So it starts with the potential and then eventually it runs out of all that?
yeah.
Okay. And you're saying the only time it's lost is when? Or,
Like it's kind of like, it's not like lost, it's just converted to like, it loses energy when the sound is made because the energy goes
Okay.
to the sound, and like it goes to this tiny bit of heat because of the friction, so it's kind of like leaving, so eventually like all of it's gonna be converted to that and leave.
so throughout the whole process being converted and it's leaving?
Yeah.
Okay. And then when it's done bouncing, does it have any energy right now?
Yeah.
It does? Okay. What kind of energy is in it now? It's a tough thing to do first thing in the morning, I know.
4 hours of sleep.
Oof, man.
That's what I get for going out.
It's Thursday.
Exactly. I'm just gonna go with the potential.
Just gonna go. Alright. Right on. Okay. So my last question. You're saying it's potential right here. Does it have the same amount of potential right here as it does when you hold it right here?
No,
No. Why?
there's more.
Has more. Okay, why?
Because because like it moves, it has the ability to do more when you like hold it up here
You ready to be done?
A little bit.
A little bit. Hey, there we go. Honesty. All right. Sweet.